Now you will go through the design and test bench code of an 8-bit reset-aware up-down counter. A counter will count the number of clock signals on its input. Here is the design module. The module name is counter and ports are clock, reset, and U-down bar, which are inputs, and an 8-bit output port named count. When up-down bar is high, the counter should count upwards, and when it is low, downwards. The functional description, and always block is used. Its sensitivity list is given as the positive edge of the clock. Thus, when synthesized, it will implement a sequential circuit which is sensitive to clock changes. The first thing to check in any reset-aware procedural block is the reset signal. If an active reset is present, it should get the highest priority over any other inputs, and should make output to the resetted state. Here, if the reset is low, output port count is set to 0. If reset is not active, go to the functionality of the circuit. Thus in the else part, if up-down bar is high, the counter should increment the count on every clock else decrement. This always block is executed on every positive edge of the clock, thus if the up-down bar is high, count is incremented 1 here, and if it is 0, count is decremented by 1. When synthesized, this will implement an 8-bit, reset-aware, up-down counter. This is the general structure of any reset-aware circuit. Here is the test bench module for the counter. First is internal signal declaration. Next, the module counter is instantiated with name counter1, with the ports connected to signals CLK, reset, U counter and count. Here is clock signal generation and reset generation. The functional code is written in an initial block, which will wait for reset, make up counter 1 for 20 clocks, down for next 12 clocks, and again 1 for next 10 clock, followed by $finish call. The program is simulated now. You can see that, after reset, the counter is counting up for 20 clocks from 0 to hexadecimal 14, which is decimal 20. It is counting downwards for the next 12 clocks, and again upwards for next 10 clocks before ending the simulation.